What's going on, guys? Let's look at an example on open circuit method. Here the question is asking the diodes D1 and D2 in the figures are ideal and the capacitors are identical. The product RC is very large compared to the time period of the AC voltage. Assuming that the diodes do not break down in the reverse bias, the output voltage VO at the steady state is what? So here the question is asking for the VO voltage, okay? And whenever we have a sinusoidal or like AC voltage, it's always better to do the open circuit method. If it's DC voltage, it's better to do the short circuit method, okay? So this is one thing we have to remember. And when it's open circuit method, what we do is we remove this diode and replace that one with open circuit. So here we are going to have an open circuit here, and also we are going to have the sinusoidal, or we can say AC voltage. We replace that one like if you look at the positive half cycle, the peak value is going to be 10 voltage, right? So peak value is going to be 10 voltage. So we can just write the peak value, that is 10 voltage right here, 10 voltage. And for a diode, this side is the anode side and the line side is the cathode side. So here we are going to have the V anode, and the voltage cathode side, okay? And here in the bottom also same thing, this is anode side and this is cathode side. So here we are going to have VA and this is going to be VK. And when we have this kind of problem, we connect the common terminal to the ground. So we connect this one to the ground, and also the voltage across this one, and these two are equal capacitance, and the voltage across this one, let's call this one V1 and let's call this one V2, okay? So this is the one right here, and we are going to have the same thing here, okay? Here we are going to have the same thing, and this is connected to the ground, and here we have a resistor, and we are interested in finding the voltage across this resistor. That's the question, VO, okay? Now here you can see this VA is connected to this 10 voltage. So this VA is going to be 10 voltage. This is 10 voltage and this is also 10 voltage, and this VK is connected to the ground. It means this is 0 voltage and this is also 0 voltage. And when we deal with ideal diode, we have to know one thing: if the VA is greater than VK, this is a short circuit. If the VA otherwise, or we can say otherwise, it's an open circuit, it's in reverse bias. If VA is greater than VK, this is short circuit. It means the diode is on. It means it's in the forward bias, okay? So this means this is on and this is in forward bias, so we have to replace this one with short circuit. Now the diagram is going to look like this. We are going to replace this one with short circuit. So we are going to have the circuit like this, and 10 voltage, we can say plus minus 10 voltage, and if we assume the direction, plus minus 10 voltage. And also here we are going to have a short circuit, and this is going to be like this. Here we are going to have like this, and if you flip this around, this is going to be plus minus, and this is going to be minus plus, okay? And this one is V1, this is V2, and this is what you are interested in, RV0, voltage across the resistance. Now let's apply KVL right here. Negative 10, if we assume the current is in this direction, let's call this I1, or yes, call this I1, and I2. If we assume, like if you apply KVL at this loop, this is going to be negative 10 voltage, because current is going through minus to plus. So negative 10 voltage, and this is plus to minus, plus V1 is equal to 0. Therefore V1 is equal to 10 voltage. And in the bottom, this is going from plus to minus again. So this means this is plus 10 voltage. This is going from plus to minus. Here this is minus to plus, right? This is plus to minus, plus 10 voltage, and here this is going from minus to plus. So this is going to be negative V2. Therefore we are going to have, that is equal to 0. Therefore we are going to have V2 is equal to 10 voltage. So we are having equal voltages. This is 10 voltage, this is 10 voltage. Therefore, if we apply KVL for this loop, this is gonna be minus V1, and this is going in this direction, so plus VO, and then again plus V2 is equal to 0. This is V1 is equal to 10, so minus 10 plus VO plus 10 is equal to 0. Minus 10 plus 10, that's equal to 0. Therefore, VO is equal to 0. So the equivalent circuit is going to look like this. Equivalent circuit, we can write it as, since the voltage across the capacitance is 10 voltage, we can replace the voltage source right here, 10 voltage, and this is also equivalent circuit, like this is capacitance, and this is also 10 voltage, and here we have the resistance, and again here we have the capacitance. The voltage across the capacitance is 10 voltage. This is minus plus 10 voltage, and here we are going to have the same thing, minus plus 10 voltage, and that's it. And this one connected to the ground. Okay, so we found out V and the voltage across here is 0 voltage. VO is equal to 0 voltage. That's the final answer, 0 voltage. And that's how we do this kind of problems. I hope this helps. Thanks for watching.